So to add or subtract, you need a least common denominator, but if you're going to multiply or divide, you don't need an LCD. In fact, to multiply or divide, you actually just multiply straight across and then reduce. However, I think it's much easier if you actually reduce before you multiply. You'll have smaller numbers to work with. So what I mean by that is we look for a common factor that we can divide out of both the top and the bottom. And so I noticed that 4 and 20 are both divisible by 4. 4 divided by 4 is 1, and 20 divided by 4 is 5. And then to do the multiplication, I just go straight across. 7 times 1 is 7, and 5 times 5 is 25. And that's my answer. Now, I would like to point out you could have multiplied straight across before reducing. You would get 28 over 100, but then you would have to recognize that 4 is a common factor, and that reduces to 7/25. If you want to divide fractions, division is defined to be multiplying by the reciprocal. What that means is you copy down the first fraction, and you can change it to multiplication, but then you have to flip the second fraction. Some people remember division as copy dot flip. That's this idea that you've only flipped the second fraction and you change it to multiplication. And now this problem I can solve using the same process I did above. I would start by looking for common factors. 5 and 15 are divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. And 6 and 4 have a common factor of 2. 6 divided by 2 is 3. Negative 4 divided by 2 is negative 2. And then if I multiply straight across, I get a negative 2 over 3 times 3, which is 9. Now, if you want to multiply or divide with mixed numbers, you have to change these into improper fractions. 2 times 6 is 12, plus 1 is 13. So 13/6 divided by 1 times 3 is 3, plus 1 is 4, 4/3. And now this problem is exactly like the one we just did. We copy down the first, change to multiplication, flip the second. And then we can multiply straight across. Although I see a common factor, 3 and 6 are both divisible by 3. And so then if I go straight across, 13 times 1 is 13, 2 times 4 is 8. And finally, because I started with mixed numbers, I'm going to end this problem with an answer as a mixed number. And so 8 goes into 13 one time, with 5 left over, and so my answer would be 1 and 5/8. Finally, we can combine all of this information together in more complicated problems. We will have to remember our PEMDAS, our order of operations. So let's see, in example 6, I have to do parentheses first. There's nothing to do in the parentheses. Then I have to do the exponent. So I have to figure out what is 3/4 times 3/4. I just multiply straight across, and I get 9 over 16. So 3/4 squared is 9/16. This problem is now 1/2 times 1/3 minus 9/16. Okay, so I did exponent, now I multiply. 1/2 times 1/3, I go straight across and I get a 1/6 minus 9 over 16. And then I finish with addition or subtraction. To subtract, I need a common denominator. So let's see, 16 is 4 times 4. And each of those 4s is a 2 times 2. 6 is 2 times 3. So my LCD is going to have those first 4 2s, everything from the first one. And then when I look at the 6, I already have a 2 written down, but I need the 3. And so if I multiply all of those numbers together, I should get 48. So my LCD is 48. That means I have to take the 1/6 times 8 over 8. That gives me 8 over 48. And I have to take the 9 over 16 times 3 over 3. And I get 27 over 48. I have a common denominator, so I can subtract the numerators. It's definitely going to be negative. 8 minus 27. Well, 27 minus 8 is 19. So negative 19 over 48. You should check and see if that fraction can be reduced. This one can't. That's my final answer. Now to work with decimals, if you want to add or subtract, the main idea is you have to make sure that the decimal lines up when you do the addition or the subtraction. So if I want to take 3.568 and add that to 12.3, I just want to make sure that when I write those numbers down, the decimal point adds up. Technically, there are zeros after the last number in a decimal. You can put those in if that helps you. And so then when I add, I would get 8, 6, 8. And the decimal doesn't move, and then a 5 and a 1. So my answer is 15.868. The same is true with subtraction. We want to make sure the decimal lines up. But when you're doing subtraction, make sure that you always put the bigger number on top. So the 6.2 has to go first, and then the 4.67. And then I'm going to subtract. Now here, it really helps me to put in that 0 after the 2 so I can do the subtraction. Let's see, I'm going to have to do a little bit of borrowing here. I'm going to borrow from the 2. So now I've got 10 minus 7 is 3. And then I have to borrow again. So now it's 11 minus 5 is 6. Decimal doesn't move. 5 minus 4 is 1. So when you do the subtraction, you have to write the bigger number down first. However, in the original problem, the smaller number was first. And what that tells me is that the answer is negative. Smaller number minus the bigger number means that answer is negative. So my answer is negative 1.63. So when you add or subtract, the decimal doesn't move. You want to make sure that you keep it lined up. However, when you multiply or divide, it turns out the decimal is going to move. To do this multiplication, the first thing you can do is you can actually pretend like the decimals aren't there and just multiply like you normally would. So 1 and 5 is 5, 1 and 2 is 2, 1 and 3 is 3. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 3 is 12, plus 1 is 13. So I add and I get 5, 2, 3, 3, 1. So the first thing I do is I ignore the decimal. And then to place the decimal, I count how many places after the decimal was in the original problem. This number has 1 digit after the decimal. This number has 2 digits after the decimal. So altogether, I have 3 digits after the decimal. And so that means my final answer has to have 1, 2, 3 digits after the decimal. So my final answer would be 13.325. So you're going to multiply ignoring the decimals, and then you place the decimal after you do the multiplication. Now, division is the opposite. We're actually going to move the decimal before we divide. And the idea is the number you're dividing by, the divisor, can't have a decimal in it. And so in this case, I'm going to take the decimal and I'm going to move it one place to the right. I'm going to clear the decimal. The rule is then with the other number, I have to do the exact same thing. Move the decimal one place to the right. So this problem becomes 48.1 divided by 4. So the idea is you are allowed to move the decimal as long as you do the exact same thing to both numbers. So I moved it 1 to the right. I had to do that for both numbers. And then this becomes a long division problem. 48.1 divided by 4. 4 goes into 4 one time with a remainder of 0. So I bring down the 8. 4 goes into 8 two times. Oh, another remainder of 0. So I bring down the 1. And the decimal's not going to move. The decimal's going to stay where it is. Now, 4 doesn't go into 1. 1 is too small. And so what you can do when you're dividing with decimals is you can always add zeros at the end of your decimals, after the decimals. So I'm just going to add a 0. And so let's see, 4 does not go into 1. So I'm going to put a 0 there. And then I'm going to bring down the next number, which is a 0. 4 goes into 10 two times. 2 times 4 is 8. I have a remainder of 2. And you can keep adding zeros until you no longer have a remainder. So I'm going to bring down another 0. 4 goes into 25 times. Oh, and it goes in exactly 5 times. I don't have a remainder, and so I'm done with the problem. And so my final answer would be 12.025. So I know this was a quick review of fractions and decimals. As always, please let me know if you have any questions on this material. I'm more than happy to go over this stuff a little bit more slowly with you during office hours.